In this video I'm going to discuss the use of matrices to model the inputs and outputs of an economy, and the use of matrices to do this was first devised in the 1970s by Vasily Leontif, and so this is known as the Leontif Model of an economy. So let's imagine, for simplicity, we just have an economy with two industries, a coal industry and a steel industry. Now, the coal industry produces a certain amount of value each year, but it doesn't produce that without some sort of raw materials and raw inputs. So let's say that the coal industry requires 20% of its output to be put back as input. This is the requirement to keep the coal industry going. And it also requires some steel from the other industry there. And let's say that for every $1 million of output, the coal industry requires $400,000 worth of steel to be used. So these numbers represent how much raw materials are needed for every unit of output. Obviously these things will have to be less than 1, and they'll have to add to less than 1, otherwise the output is less than the inputs and the industry is going backwards. On the other hand, the steel industry, let's say, requires every $1 million of steel produced requires $300,000 worth of coal, and every $1 million of steel requires $100,000 worth of steel to be consumed. So this matrix is sometimes called a consumption matrix or an exchange matrix. And really both terms apply, because this shows how much of the materials are being consumed by the coal industry and how much by the steel industry, but it also shows that some steel is being used by the coal industry and some coal is being used by the steel industry. So both exchange and consumption are both meaningful terms. Now, if the output of these industries was just enough to keep themselves going, we would call that a closed economy. Usually we have open economies where, apart from keeping these internal industries going, output is higher to meet demand from outside sources. So we have a demand matrix, and let's imagine that there's a demand for $24 million worth of coal and $15 million worth of steel annually to be supplied. The question then becomes, how much do each of these industries have to produce to meet their internal requirements as well as the external demand? So let's set up a column vector called X, having the values A and B, where A and B represent the annual production from each of the coal and steel industries. Now, the Leontif model is written in the form of a matrix equation. X equals the exchange matrix times X, and this would calculate internal demand, plus D, external demand. So think of this as total production must meet internal demand plus external demand. To solve for X, the first step is subtract MX from both sides. Now, remembering that we can multiply by the identity matrix, this now can be factored, I minus M times X equals D. Instead of the opposite of multiplying by this, then we'll have to multiply by the inverse, if it exists, times D. And now I'll substitute. Identity matrix is diagonal ones. The consumption matrix, 0.2, 0.3, 0.4, 0.1. Now, once subtracted, I need the inverse of these, and then multiply by the demand, 24, 15. So we could do this by hand, but because the focus of this question is really more about the Leontif model, I'm going to use the calculator. So I'll just enter this exactly as it seems. Start with some matrices. I'll need a 2 by 2 matrix. Subtract the consumption matrix. Now close the brackets, do the inverse, and now multiply by the demand, which is the vector 2415. And in one go I get the result 43.536. So let's interpret this result. This means that annual production from the coal industry must be 43.5 million and annual production from the steel industry must be 36 million. We should check that this actually satisfies what we set out to do. Now remember, this decimal 2 means the fraction of the coal industry output. Now we think that's 43.5. So I have 0.2 times 43.5 as an input to keep the coal industry going. This number, 0.3, is the input to the steel industry from the coal industry, and that 0.3 means 0.3 of the steel industry's output. So I think the steel industry needs to make 36 million annually, so that's 0.3 of 36. This will keep the coal industry going. This will keep the steel industry going to the point where it can make this much. And I still have the external demand of 24 million annually. Now, we'll just quickly work this out. 43.5. And it comes to 43.5 million. Which is exactly what we need. This is the internal demand on the coal industry. This is how much coal, value of coal, the steel industry needs, and the external demand. That's exactly what we got. Now we could check the 36 by doing the similar process, and I'll just demonstrate that quickly. So, steel industry produces 36. 0.4 of the coal industry's value. Coal industry's value was 43.5. 0.1 of the steel industry's value must be put back in. So 0.1 of 36. And there should be enough left over for 15 million of external demand. And we get 36 million required. So that confirms that our result here was correct. Now, in the event that the demand matrix was 0, we'd have what's called a closed economy, and you would be finding the value of the production just to keep this industry going on its own.